Hello everyone, welcome back to the Basic Electronics 18ELN14 Module 4 Session 3. Module 4, the topic is the BJT applications, feedback amplifiers and oscillators. Under that we have seen till now how the BJT acts as an amplifier and as well as how it is working as a switch. Moving on to the third session, there we have the transistor switch circuit to switch on or off an LED and a lamp in a power circuit using a relay. The contents here is the introduction to the transistor switch circuit to switch on or off an LED and a lamp in a power circuit using a relay. Under that we'll be seeing varieties of examples. One of the example is the NPN relay switch. Next, the simple application how a transistor can be used as a switch. Next, another important concept will be moving on is to the feedback amplifier. Under the feedback amplifier, we'll be seeing what is a feedback, what is an amplification process, introduction to it, and the working principle of a feedback amplifier. The transistor switch circuit to switch on or off an LED, a lamp in a power circuit using a relay. When a transistor is turned on, current flows through the collector and emitter, thus lightening the LED. At the same time, on the contrary, when we see that the transistor is turned off, the transistor acts as an insulator. When the transistor acts as an insulator, there will be no current flow and hence LED doesn't light. This is the basic concepts of a transistor acting as a switch. With a zero applied signal to the base of the transistor, it turns off. But with a positive signal applied to the base of the transistor, it turns on. This concept is applicable only for common base configuration of a transistor when the common base configuration is the common emitter configuration when the input is applied to the base. With a positive signal applied to the base of the transistor, it turns on, acting like a closed switch, and maximum circuit current flows through the device. With a zero signal applied to the base of the transistor, it turns off, acting like a open switch, and the current doesn't flow in the collector. This forms the transistor switching action to switch on or off an LED and a lamp in a power circuit using a relay. One of the example we can consider the famous quote is from the NPN relay switch. When power is applied to the coil due to the switching action of the transistor, a maximum current will flow as a result of the DC resistances of the coil as defined by the Ohm's law. Ohm's law is V is equal to I into R. Some of this electrical energy is stored within the relay coil's magnetic field. Okay, so when the switch has been closed, the region of operation is in saturation. When the switch has been opened, the region of operation is in the cutoff. Hence, the switching action takes place between the cutoff and the saturation region. In the cutoff region, no current flows because it acts as an open switch, whereas in the saturation region, the current flows because it acts as a closed switch. The simple application of a transistor switch is whenever the input has been applied to the base of the transistor, here as it is being shown in the figure, that is a square wave input has been applied to the base of the transistor. When the square wave goes to logic 1, then it is in the off. When it is in 0, then it is in off condition. So when it is in on condition, it's a logic 1. When the square wave goes to the high level, that is logic 1 condition, the transistor goes for saturation. But when the input logic 0 is been applied to the base, that is in the off condition, then the transistor goes into cutoff. Then no current flows, and hence the switch will be opened, that is the transistor will be opened. Now when the transistor is in saturation, biasing, forward bias takes place, and the LED will glow, and the resulting LED will glow in the collector to the emitter junction. Okay, then this causes the LED, the current flows through the LED and it causes to emit light. The light has been emitted from the LED only when the IC current flows, that is the collector current flows in the forward bias region. This is one of the simple application of a transistor switch. Next, moving on to very important and interesting concept is a feedback amplifier. What is a feedback amplifier is, here it is an amplifier which has feedback lane. It is an amplifier which has a feedback lane that exists between output to input. An amplifier circuit simply increases the signal strength from, say for example, if input voltage is 1 volt, the output will be greater than 1 volt. Hence the strength of the signal is increased. Okay, but while amplifying, it just increases strength of the input signal, whether it contains information or some noise along with some data. This noise or some disturbances is introduced in the amplifier because of their strong tendency to introduce them due to the sudden increase in the temperature changes in the which is being placed in the environment. Therefore, every high gain amplifier tends to give noise along with signal in its output. This noise is undesirable. Hence, the noise level in the amplifier circuit can be considerably reduced by using negative feedback done by injecting a fraction of the output in phase opposite to the input signal. For every high gain amplifier tends to give noise along with the signal in its output, which is very undesirable. Hence, output will have a noise along with it. This noise, undesirable noise, should be reduced. Therefore, the noise level in the amplifier circuits can be considerably reduced by using negative feedback done by injecting a fraction of a output in phase opposite to the input signal. Hence, a feedback amplifier means consists of two parts. Here, amplifier gain and the feedback circuit. The feedback circuit usually consists of the resistor. Okay. Now, in the feedback can be defined here. What do you mean by a feedback? Means it can be defined as an amplifier which has a feedback, which has a partial of the output which is being fed back to the input. Okay, that is, in this type of amplifier, feedback is a limitation which calculates the sum of the feedback given in the amplifier, that is gain. Gain is always output by input. The feedback, here you have something called as feedback circuit, which calculates the feedback factor. This feedback circuit or the feedback factor is a ratio of the feedback signal and the input signal. So feedback is a design technique where a part of the amplifier output feeds back to the input of the amplifier. The overall effect creates a very stable gain determined by the resistors ratio. So having this just introduction concept of the feedback amplifier, we'll just look into more detail in the next coming session. To have a deeper concept, please refer to the prescribed textbook, and these are the few references which has been taken care of. Okay. Thank you.